Returns to a factor describe how output changes when additional units of a variable input, such as labor, are added to a fixed amount of another input, like land or machinery. There are three main types of returns to a factor: increasing, constant, and diminishing returns. Increasing returns occur when each additional unit of the variable input leads to a larger increase in output, meaning the marginal product rises. Constant returns are observed when each added unit of input results in the same increase in output, so the marginal product remains unchanged. Diminishing returns set in when each extra unit of the variable input adds less to output than the previous one, causing the marginal product to decline. These concepts help us understand how efficiently resources are being used in production. Returns to a factor and returns to scale are two important concepts in production analysis, each focusing on different aspects of input changes. Returns to a factor examine the effect of varying a single input while keeping all other inputs constant, typically in the short run. In contrast, returns to scale consider the impact of changing all inputs simultaneously and proportionally, which is usually analyzed in the long run. The proportions of factors remain unchanged in returns to scale, whereas they shift when studying returns to a factor. Additionally, returns to scale are associated with changes in the overall scale of production, while returns to a factor relate to adjustments within a fixed production capacity. These distinctions help clarify how businesses respond to input variations over different timeframes and production scenarios. The average product and marginal product are closely linked concepts in production analysis. Marginal product refers to the additional output generated by adding one more unit of input, while average product is the total output divided by the number of inputs. When the marginal product exceeds the average product rises. If the marginal product equals the average product remains constant. Conversely, when the marginal product falls below the average product declines. This relationship helps producers understand how changes in input levels can influence overall efficiency and output. Total product refers to the overall quantity of output produced by a firm using a given amount of inputs. Marginal product, on the other hand, measures the additional output generated by adding one more unit of input. As total product increases, marginal product typically rises at first, reflecting increasing efficiency. However, after reaching a certain point, marginal product begins to decline due to diminishing returns. When marginal product is zero, total product reaches its maximum, indicating that adding more input does not increase output. If marginal product becomes negative, total product actually decreases, showing that additional input is counterproductive. This relationship helps firms determine the optimal level of input for maximum production efficiency. Increasing returns often arise in the early stages of production due to the more effective use of fixed factors, such as machinery, buildings, or management. As output expands, these resources can be utilized more fully, reducing idle time and spreading costs over a greater number of units. Additionally, the division of labor becomes more pronounced, allowing workers to specialize in specific tasks. This specialization leads to improved skill, faster work, and fewer mistakes. Together, fuller utilization of fixed factors and enhanced division of labor contribute to greater efficiency and higher output. These effects are most noticeable when production is just beginning to scale up, before any constraints or diminishing returns set in.